Okay, and what we're going to do today, we're going to take a look at the last section or the topics that are in the 1.4 set of notes. So just give me 1 second to get set up here. All right, so today we're going to look at reciprocal functions. We're going to look at cofunctions. We're going to kind of review the 6 trig functions once again as they relate to a triangle. And we're going to actually solve a right triangle. Okay, when you solve a right triangle, that means to find all of the side lengths and all of the angle measures. So I'm going to go to the lecture notes. And for today, we're going to actually concentrate on the 8.2 and the 8.3 set of notes. All right, so I'm just actually going to bring both of those up. And first, we're going to start with 8.2. And we're also going to use the calculator. So I'm going to bring up the calculator. Okay, and I want to talk about reciprocal identities. And for reciprocal identities, okay, we have the following. Now, as far as the formula sheet is concerned, the all exam formula sheet, I'm going to bring that up for a second. I don't believe that the reciprocal, just give me 1 second to bring that up. This is the all exam formula sheet. Okay, and we have the reciprocal set of formulas that are on this formula sheet. Now, the reciprocal formulas are used mainly when you are asked to find the values of the reciprocal functions using the calculator. But here are the reciprocal functions in all their glory. So we have the sine of theta, that's equal to 1 over the cosecant of theta. The cosine of theta is equal to 1 over the secant, and the tangent of theta is 1 over the tangent of theta. Now, we don't use the first three very rarely because on the calculator, we have a sine, a cosine, and a tangent function, right? For example, I'm just going to turn on my calculator. And since I'm dealing with a trig function, you have to be mindful of what mode your calculator is in. Since I'm going to work with degree measures, I'm going to make sure that my calculator is in degree mode. Right? So I went into mode, I found degree, and I just set that in with enter. So now my calculator is in degree mode. So for example, if I wanted to find, let's say, the sine of 30 degrees, because I'm in degree mode, notice I have 0.5. I can also find, let's say, the tangent of 45 degrees, right? That's equal to 1. And I can also find the cosine of 60 degrees, which is, again, is 0.5. However, when I'm asked to find cosecant, secant, and cotangent values, I do not have a cosecant, secant, or cotangent function on the calculator. Now, this function that you see above sine, that's not the cosecant. Right, the function above sine is called the arc sine. The arc sine, or these arc functions, or sometimes they're called inverse functions, they're used to find angle measures. Whereas sine, cosine, and tangent are used to find side lengths. So let's say, for example, we're asked to find the cosecant of, let's say, 30 degrees. And notice we have reciprocal formulas for our cosecant, right? The cosecant of theta, that's equal to 1 divided by the sine of theta. The secant of theta is 1 divided by the cosine of theta, and the cotangent of theta is equal to 1 divided by the tangent of theta. Okay, so here's an example. Let's just say that we're asked to find the cosecant of 120 degrees, right? Now keep in mind we don't have a cosecant function on our calculator, but we do have a reciprocal function, right? The reciprocal function for cosecant says that it's equal to 1 divided by the sine. So if I were asked to okay, so I'm going to just make my directions here. We're going to use a calculator. I'm going to write this out as the cosecant of 120 degrees. I'm going to write that as 1 divided by the sine of 120 degrees. Okay. And I'm going to put 1 divided by the sine of 120 degrees into the calculator. Right? So since I am in degree mode, right, I'm given a degree measure. I'm in degree mode. So I'm going to enter 1 divided by the sine of 120 degrees. And we have 1.154. All right, so the cosecant, that's equal to 1 divided by the sine of 120. All right, so we have what's called an approximate value, and we have what's called an exact value. So here we have the approximate value. Okay, now if we were asked to find the exact value, all right, so I'm just going to do that. So I have the cosecant of 120 degrees. That's equal to 1 divided by the sine of 120 degrees. So I'm going to pull up my unit circle. And if I find 120 degrees, which is 2 pi over 3, notice that 120 degrees, we have the coordinates negative 1/2, comma, square root of 3 over 2. So remember that the sine is our y-coordinate. So the sine of 120 degrees is square root of 3 over 2. So that's 1 divided by the square root of 3 over 2. Right. So now I'm going to use a trick that you may see often. We have 1 divided by the square root of 3 over 2. If I have 1 in my numerator, and if I have a fraction in my denominator, 1 divided by the square root of 3 over 2 is actually 2 divided by the square root of 3. All right. Now, whenever we write out our radicals, we want to make sure that we rationalize the denominator, right? So we want to make sure that there are not any radicals in the denominator. So we're going to rationalize the denominator. So in order to rationalize the denominator, give me 1 second, I'm going to turn my phone off. Right? I'm going to multiply 2 times the square root of 3 by the square root of 3 over 3, right? Because the square root of 3 over 3, that's a special form of 1. So anytime I multiply something by 1, I don't change the value, right? Because I'm multiplying by 1, but I can change the way that my fraction is expressed, right? So I'm simply going to multiply the numerator. So 2 times the square root of 3 is 2 square root of 3. The square root of 3 times the square root of 3 is the square root of 9. And the square root of 9 is perfectly 3. So I have 2 square root of 3 divided by 3. This is considered the exact value. Now, keep in mind, we can also find these values, okay, if we're dealing with a unit circle, we can find these values in this unit circle function values chart. Right. So if I were asked to find, let's say, the cosecant of 120 degrees, I could locate 120 degrees. I can find the column for the secant, and I have 2 square root of 3 divided by 3. So this table gives you the exact values. All right, so we looked at a couple of ways to find the cosecant, right? So if you were asked to find the secant or the tangent, you would refer to the reciprocal formulas, right? You would refer to these reciprocal formulas. Okay, so this kind of explains from everything that's out of section 8.2, okay, that we sort of need for our purposes. The next thing I'm going to do is open up the 8.3 set of notes, and we're going to talk about the 6 trig functions. Now, the 6 trig functions, here again, if I were to take a look at the all exam formula sheet, the 6 trig functions are basically the only functions that I would require you to memorize or have some idea of the 6 trig functions when you see them. And they're sort of twofold. Right? So what I mean by twofold, notice that if we're in an x and a y axis system, right, when we talked about the unit circle, right, that unit circle is in an x and y axis system. We had the first set of functions. So the sine of a, that's equal to y over r, right? So keep in mind, in the unit circle, the radius is 1. So in order to find the sine of any angle, we simply locate the y coordinate. The cosine is x over r, right? So again, in the unit circle, the radius is 1. So we can find the cosine of any angle in the unit circle, right, by simply denoting the x value. And then we have the tangent as y over x, and we have those reciprocals. Notice we also have another set of the trig functions, and they deal with triangles that are not in an x and y axis system, right? So we talk about opposites, adjacents, and hypotenuses. So there's a saying for the 6 trig function, and it's Chief Sakatoa, and we'll talk about that in just a second. And it kind of alludes to the first 3 trig functions. The sine is the opposite divided by the hypotenuse. The cosine is the adjacent divided by the hypotenuse. And the tangent is the opposite divided by the adjacent. And then we have our reciprocals. The reciprocal of sine is cosecant, and the cosecant is the hypotenuse divided by the opposite. The secant is the hypotenuse divided by the adjacent, And the cotangent, which is the reciprocal of the tangent, is the adjacent divided by the opposite. Okay. All right, now let's look at an example. And in this example, we're asked to find the sine of A, the cosine of A, and the tangent of A. All right. All right, so I'm going to recreate the triangle. Well, I'm going to try my best to recreate the triangle. So this is C, B, and A. Now, whenever we draw out these triangles, we use what's called standard labeling. And in standard labeling, capital letters represent angle measures. Lowercase letters represent side lengths. So here we can see I have angle A, angle B, and angle C, and they're all capitalized letters. Now, as far as the side lengths are concerned, okay, here I have angle C. The side that's opposite angle C, that side length C, right? And that side length C was 25. The angle that's opposite angle, the side that's opposite angle A is side length A, and that was 7. And we have angle B, and the side that's opposite angle B is side B, and that was 24. Now, I'm kind of drawing this out because in some of the homework problems, they give us triangles, and in other problems, we're not given any triangles, we're just given a set of measurements. So if you're asked to sketch out a triangle, you would sketch it out as follows, right? So now we're actually going to find the sine of A, the cosine of A, the tangent of A. We're also going to find the cosecant of A, the secant of A, and the cotangent of A. Right, we're going to find all 6 trig functions. Now, whenever you set up a trig function, I'm just going to mention this. We have chief, SOHCAHTOA, right? So this chief SOHCAHTOA is a mnemonic device or a saying that helps us to remember a formula. So here's what it alludes to. It alludes to, in chief SOHCAHTOA, the side part alludes to the fact that the sine is the opposite over the hypotenuse. Okay, I'm going to use theta. The chi part of chief SOHCAHTOA alludes to the fact that the cosine of some angle is the adjacent side over the hypotenuse. And the TOA part of chief SOHCAHTOA alludes to the tangent of some angle is the opposite side over the adjacent side. All right, so we have chief SOHCAHTOA. Right, and we're going to use that to find the sine, the cosine, and the tangent. The first thing we need to do is we need to locate our reference angle. And since we're trying to find the 6 trig functions for A, our reference angle is A. Remember that the definition of a reference angle is simply it's any acute angle. All right, so we located our reference angle. And now I'm going to label my sides according to the reference angle. So I have to label my adjacent, my opposite, and my hypotenuse. When I'm labeling my triangle, I always like to start with the hypotenuse. Keep in mind, for any right triangle, the hypotenuse is opposite the right angle. Right, so I have my right angle is angle C. So the hypotenuse is going to be opposite angle C. So here we have our hypotenuse. Next, I'm going to label out my adjacent. Well, excuse me. Next, we'll lay out the opposite. So we have angle A. The side that's opposite angle A is side length A. So side length A is opposite to angle A. So that's our opposite side. And then lastly, we have our adjacent side. So our adjacent side is going to be side B. So that's adjacent to angle A. So now we're just going to simply list out our trig functions. So from Chief Sokotoa, the sine is the opposite over the hypotenuse. So our opposite side is 7. Our hypotenuse is 25. So the sine of angle A is 7 over 25. Next, we'll find the cosine of angle A. So for Chief Sokotoa, the cosine is the adjacent over the hypotenuse. So our adjacent is 24. Our hypotenuse is 25. So the cosine is 24 over 25. And then lastly, we have the tangent. So from Chief Sokotoa, the tangent is the opposite, which is 7, over the adjacent, which is 24. And now we'll list out the reciprocals. So the cosecant, that's the reciprocal for the sine, that's 25 over 7. The secant, which is the reciprocal of cosine, that's 25 over 24. And the cotangent, which is the reciprocal of the tangent, is 24 over 7. Right? So we have our 6 trig functions. Now, what I would like for you to do, okay, using the same triangle, I want you to find the sine for angle B, the cosine of B, the tangent of B, and the reciprocals. The cosecant of B, the secant of B, and the cotangent of B. All right, so at this time, right, I'm going to pause the video. Okay, I'm going to give you a couple of seconds to work out the problem, and then we're going to return with the solution. All right, so now we're going to return with the solution. All right, so whenever we set up a trig function, and this is going to be important as we progress further through the course, we're going to refer to chief Sakator. We have to pick a reference angle. So in this instance, we're asked to find the 6 trig functions for angle B. So our reference angle is B. And now we're going to label all of our sides according to angle B. The first thing I'm going to do is always list out the hypotenuse. So here again, I have my right angle as angle C. The side that's opposite angle C is side length C. That still serves as my hypotenuse. All right, the hypotenuse isn't going to change. But what will change is the opposites and the adjacents. Okay, so since I'm dealing with angle B, next I'm going to list out the opposite. So the side that's opposite angle B is side length B. So side length B serves as my opposite, right? So that's opposite to angle B. And side length A serves as my adjacent to angle B. So I have my hypotenuse, my opposite, and my adjacent listed, right? So now let's refer to chief Sakator. So the sine is the opposite over the hypotenuse. So that's 24 over 25. The cosine is the adjacent over the hypotenuse. So that's 7 over 25. And the tangent is the opposite over the adjacent. So that's 24 divided by 7. Next, we'll list out the reciprocal. So the reciprocal of cosecant is sine. So that's 25 over 24. The reciprocal of secant is cosine. So that's 25 over 7. And the reciprocal of cotangent is tangent. So the cotangent value is 7 over 24. Right. All right. So any questions? Well, okay. So this is the 6 trig functions for the triangle. Next, we're going to talk about cofunctions. Okay, and this is sort of the reason that we went through finding the 6 trig functions for A and B. Now, you never find the 6 trig functions for angle C or your right angle, okay, because angle C is not an acute angle. All right, so you only want to find your 6 trig functions as they relate to your acute angles. All right, next we're going to talk about cofunctions. Now, in a right triangle, okay, ABC, with C being your right angle, right? The acute angles A and B are complementary. So complementary angles are 2 angles. When added together, they give you 180. Now, there's certain facts about a triangle or a right triangle. For a right triangle, and I'm going to go back to OneNote for just a second. So this is right triangle facts. Okay, for a right triangle, the hypotenuse is always the longest side. In any right triangle, the hypotenuse always is the longest side. So we have the hypotenuse, and then we have the 2 legs, right? Another thing about a right triangle, well, this is true for any triangle. There are a total of 180 degrees in every triangle. Okay. So that means that the sum of the interior angles for any triangle must be 180 degrees, right? So like if this is 90 degrees, then angles A and angle B would have to they would have to add together and give us 90 degrees for the total of 180 degrees at every triangle, not necessarily a right triangle, but every triangle must have, right? So these are two facts. The hypotenuse is always along its side, and there are a total of 180 degrees in every triangle, right? So angles A and B must total together to give us 90. And it says that sine A is equal to cosine B, and it says that the functions for sine and cosine are called cofunctions, right? Similarly for secant and cosecant, and tangent and cotangent, right? So based on the triangle we were just working with, we're going to test out these cofunctions. All right, so let's test out some of the cofunctions. I'm going to shrink that slightly. All right. All right, so we have that the sine of A, that's equal to the cosine of B. So let's see if that's actually true. So we see that the sine of A is 7 over 25. The cosine of B is also 7 over 25. Now keep in mind, this can also work in reverse. The sine of B, that should equal to the cosine of A. So let's verify that. So the sine of B is 24 over 25. The cosine of A is also 24 over 25. They have the same exact value. Right? The other cofunction, we had that the tangent of A is equal to the cotangent of B. Right? So the tangent of A is 7 over 24. The cotangent of B is also 7 over 24. Keep in mind, this also works in reverse. The tangent of B is equal to the cotangent of A. So the tangent of B is 24 over 7. The cotangent of A is also 24 over 7. And then lastly, the secant of A, that's equal to the cosecant of B. So the secant of A is 25 over 24. The cosecant of B is the same. Right? And then we can actually reverse. The secant of B is equal to the cosecant of A. So notice that both are 25 over 7. So this is just some proof that these formulas are valid. Now, as far as angle measures are concerned, we have these set of formulas. Now, one thing about the cofunction identities, these formulas are not on the all exam formula sheet. Right? I just want to point that out. If you look on the all exam formula sheet, there are no cofunction identities. The cofunction identities are found in the 8.3 set of notes. All right. And here are the cofunction identities. And notice that they're twofold. The first set of formulas deal with degree measures. The second set of formulas deal with radian measure. Right? So let's take a look at a couple of examples. So here we ask to find each cofunction. So first we're going to look at the sine of 30 degrees. All right, and we're asked to find a cofunction for the sine of 30 degrees. All right, so if we refer back to the cofunction identities, it says that the sine of A, right, that's equal to the cosine of 90 degrees minus A. Right, so as I'm finding this cofunction, I have the sine of 30 degrees, so that's the sine of A, right? So we're going to substitute A for 30 degrees. That's equal to the cosine of 90 degrees minus angle A. Right, so this is equal to the cosine of 90 degrees minus A. A is 30 degrees, so we have the cosine of 60 degrees. So the sine of 30 degrees is equal to the cosine of 60 degrees. So I'm actually going to verify this in the calculator. Right, so I'm going to turn on my calculator, and since I'm dealing with degree measure, okay, I'm just going to make sure that I'm in degree mode. I can put in the sine of 30, right, I get 0.5. I can also put in the cosine of 60 degrees, and I get the same value, 0.5. So the sine of 30 and the cosine of 60 degrees are cofunctions. All right, so let's look at another example. Right, so let's find a cofunction for the secant of pi over 6. All right, so I'm going to refer back to my formula sheet. So the formula sheet says that the secant, and notice since we're using radian measure, I'm using this second set of formulas. It says that the secant of A, that's equal to the cosecant of pi over 2 radians, right, which is 90 degrees, minus A. So the secant of A, that's equal to the cosecant of pi over 2 minus A. Right, so in this formula, I'm going to substitute A for pi over 6. So I have the cosecant of pi over 2 minus pi over 6. Right, so keep in mind when we subtract fractions, we need a common denominator. Right, so the common denominator between 2 and 6 should be 6, right? Right, so when I talk about common denominator, that's the same thing as the least common multiple. So like for the least common multiple, the multiples of 2 are 2, 4, 6, 8, 10. It keeps on going. The multiples are 6 are 6, 12, 18. It keeps on going. So my least common multiple is 6, right? So now I need to make equivalent fractions. So for this first fraction, that 2 was multiplied by 3 to get 6. So I multiply the top by 3. So that's 3 pi. My second fraction, it stays the same, right? That 6 was multiplied by 1 to give me the least common denominator. I multiply the top by that same quantity. I get pi. Right, so now I can keep my common denominator. I can combine, I can combine my numerator. So 3 pi minus pi is 2 pi. And I can reduce 2 pi over 6 to pi over 3. Right, so the secant of pi over 6 and the cosecant of pi over 3 are cofunctions. Right? Now, to actually verify, you would enter the secant of pi over 6 in your calculator as 1 divided by the cosine of pi over 6. You would get a value. You could put in the cosecant for pi over 3 as 1 divided by the sine of pi over 3. Right, to get the values. But here we're only, that's just to see that both of these things are equivalent. All right, but the cofunction for the secant of pi over 6 would be the cosecant of pi over 3. All right, next I'm going to scroll down a little bit on the lecture notes, and I want to talk about how to find an angle measure. Right, so we find angle measures, right, on the calculator by using these inverse functions, or they're sometimes called arc functions. And for these examples, we're asked to use a calculator to find an angle, and this says in degrees, that satisfies the sine of theta. So here again, the sine of some angle, and we're going to figure out what that angle is equal to 0.96770911705. And in the second example, we're asked to use a calculator to find an angle in radians. So we must be careful on the mode of our calculator that satisfies the tangent of theta, right? The tangent of some angle is equal to 0.25. All right, so let's take a look at the solution. So we're asked to find each angle. So remember, this first one was degrees. The sine of some angle is equal to 0.96770911705. All right, so just like when in algebra, right, we have an equation, right, because we have an equal sign. And whatever we do to one side of the equation, we must do the exact same thing to the other side of the equation. So what I'm going to do here is I'm going to take the arc sine for both sides of the equation. But before I do that, I want to introduce some formulas. And these are actually called identity formulas. Now, in a lot of textbooks, they sort of forego writing this out, and you're going to see as we go through. They kind of go from one step to the other step without any like explanation on how that's done. But I'm going to write out these identity formulas. And the first identity formula says that the arc sine for the sine of theta is equal to theta, right? So whatever theta is, if you're taking the arc sine for the sine of 30 degrees, that would equal to 30 degrees, right? Whatever theta is. The second identity says that the arc cosine for the cosine of theta is theta. And the last identity formula says that the arc tangent for the tangent of theta is equal to theta. Right? So now this thing is read as, so you may hear me say this a couple of ways. You may hear me say that this is the arc sine of theta, or you may hear me say this is the inverse sine of theta. Okay, so sometimes I may say it's an arc sine, or sometimes I may say it's an inverse sine, but both of these things are one and the same. Okay. So these are our arc function identities. Okay. So now this is how they're actually used. All right, so sort of going back to our problem, this is what we're given. The sine of theta is equal to 0.96, and we're asked to find the angle measure in degrees. So what I'm going to do is I'm going to take the arc sine of both sides, right? Whatever you do to one side, you must do the exact same thing to the other. So I'm going to take the arc sine for the left-hand side, and I'm going to take the arc sine for the right-hand side. So here's what happens. On the left-hand side, that forms an identity, right? The arc sine for the sine of theta is simply theta. So the left-hand side reduces down to the unknown angle measure, which we're actually asked to find. So theta is equal to, and as far as my right-hand side, the only thing I can do here is evaluate it with the calculator. So I'm going to bring back our calculator. First, let's make sure that we're in degree mode. Now, one thing about this calculator on the computer, this emulated calculator I'm using, I've noticed that the mode may reset itself. Now, in your physical handheld calculator, the only way it's going to change from radian to degree is if you physically change it. Okay, but since I'm using an emulated calculator, it may just decide to reset itself once I close it down and I open it back up. So you don't necessarily have to check your mode for every problem. I like to do so simply because this is an emulated calculator and sometimes it may reset back to the factory settings. So I am in degree mode. I'm going to go back to my home screen and I'm going to use the arc sine, and since this arc sine is yellow, I'm going to hit second and sine, which is the arc sine. I'm going to put in 0.9677091705. I'm going to close off the argument for arc sine, and we have an angle measure of 75.4 degrees. right? So an angle of 75.4 degrees has a sine value of approximately 0.96. We're also asked to find in radians an angle measure that has a tangent of 0.25. Right, so we're going to do the same thing. I'm going to take but in this instance, since I'm dealing with a tangent function, I'm going to take the arc tangent for both sides of my equation. On the left-hand side, we have an identity. The arc tangent for the tangent of theta is theta. For the right-hand side, we're going to evaluate that in the calculator. Right? Since we are dealing with a radian measure, we want to make sure that we are in radian mode. So I'm just going to lock that in with enter. I'm going to go back to my home screen, and I'm going to use the arc tangent function. So that's second and tangent, which brings up the arc tangent for 0.25. And we have 0.24 radians. All right, so we're able to find both angle measures. Now we're going to use this arc sine or these arc functions to find angle measures when we solve right triangles. All right, so I believe in this instance, I'm just going to pull up a problem. All right, so this is problem number 6. We'll take a look at number 6. All right, in problem number 6, we're given a right triangle. We're given some dimensions, right? And we're asked to find A and we're asked to find C. Let's see if it'll let me copy this. Copy image. All right, so let's use the triangle. I'll give you a second to sketch this out, and let's find A and find C. All right, so we must set up some trig functions. So the first thing I'm going to do is I'm going to label out all of my sides. Right, so I have angle A. The side that's opposite angle A is side length A. I have side C. So the angle that's opposite side C is angle C. So I'm going to use a capital C. And then for my last angle, I have angle B. And the side that's opposite angle B is side length B. Now, you may choose to find side A, you may choose to find side C, but no matter where our starting point is, all of our dimensions or all of our answers should be exactly the same. Right? So first, we're going to find side length A. Right? So since I'm trying to find side length A, hold up, and something has to be missing because I only have 1, Okay, this should be 7. I don't know why that didn't come through, but B should equal to 7. All right, so we're going to find side length A. So when we set up a trig function, we must use Chief Sokotoa. We have to start with a reference angle. Now in this instance, I'm going to start my reference angle as angle B because I know the value of angle B. Right? So I have my reference angle is B. Now I'm going to label all of my sides. First thing I'm going to do is label the hypotenuse. So I have my right angle is angle C. So the hypotenuse is opposite angle C. So side length C is my hypotenuse. Next, I'm going to label my opposite. So I have my reference angle is B. So the side opposite angle B is side length B, and that is my opposite. And then lastly, we have our adjacent. So side length A is adjacent to B. All right. So now we're going to consult Chief Sokotoa. And for Chief Sokotoa, we're going to use it to set up our trig functions. And we have 3 parameters, right? You have an angle measure, and then you either have an opposite, an adjacent, and a hypotenuse in some manner, right? So if I look back at the given information, right, I know my angle measure, and I know my opposite, right? So as I look at Chief Sokotoa, right, I have 2 setups that include the opposite side, right? I have the sine and the tangent. Since we're trying to find side length A, right? A is the adjacent. We have the opposite and we have the angle measure. So in this instance, we're going to set up a tangent function. When you set up your trig function, there must be only one unknown item. And the unknown item here is just the adjacent, right? So I'm going to write out this trig function. So I'm going to write it out as the tangent of 60 degrees. That's equal to the opposite, which is 7, divided by the adjacent, which is unknown, and we're going to call that A. And now we have to solve for angle A. Excuse me, for side A. All right, so the first thing I'm going to do is I'm going to multiply both sides by A, right? So if I multiply the left-hand side by A, and I don't know what's going on with the pen. So I'm going to multiply the left-hand side by A. I'm also going to multiply the right-hand side by A. Right, so on the left-hand side, I have A times the tangent of 60 degrees. On the right-hand side, A's cancel. I'm left with 7. The opposite of multiplying a by the tangent of 60 degrees is to divide by 60 degrees. So I'm going to divide both sides by 60 degrees. Excuse me, the tangent of 60 degrees. So if I divide the left-hand side by the tangent of 60 degrees, right, I'm also going to divide the right-hand side by the tangent of 60 degrees. Notice that on the left-hand side, the tangent of 60 degree cancels. So I have A is equal to 70 times the tangent of 60 degrees. And now I'm going to use a calculator to simplify. And this is where the mode on your calculator is important. Since I have a degree measure, I want to make sure that my calculator is in degree mode. All right, so the first thing I'm going to do is change this mode on my calculator to degree. Next, I'm going to divide 7 divided by the tangent of 60. And we have 4.04. So A is equal to 4.04. All right, so side length A is equal to 4.04. And the screen, okay, so we have A is 4.04. Now, since we're dealing with a right triangle, right, we could set up another trig function, but in order to find C, I'm going to use the Pythagorean Theorem. Right, you could set up another trig function, but as you're going to see as we go through solving right triangles, generally there's only one trig function that you set up. Right, once you set that trig function up, if you know two sides of your right triangle, you can find the third side by using the Pythagorean theorem. Right. So let me just write that over here. So the Pythagorean theorem okay, and as all its glory, here's the Pythagorean theorem. C squared is equal to A squared plus B squared. But you never really find C squared, A squared, B squared, right? You only find C, A, and B. So I can take this Pythagorean theorem and I can actually solve it for C. So I would just take the square root of both sides. So C is equal to A squared plus B squared. I can also find A. A is equal to the square root of C squared minus B squared. And I can also find side length B. B is equal to the square root of C squared minus A squared. All right, so here I'm asked to find C, so I'm going to use C is equal to A squared plus B squared. Okay, and I'm going to use my calculator. All right, now here's the thing in this course, and there's something called rounding error. And you get rounding error when you take a value that has been rounded, you use that in a calculation, and then you round again, right? You may incur what's called rounding error. In order to stay away from rounding error, you only round the last number. Okay, you never round any numbers you're using in a calculation. Which means that if I were using C is equal to the square root of A squared plus B squared, right, I would use B as 7, but I would not use A as 4.04, right? Because 4.04 was a rounded value. It's not the true value which we got over here. This 4.04145, right? So I'm going to kind of capture this true value, right? So I'm going to take this 4.04 and I'm going to store that. So I'm going to hit STO. I'm going to store that for A, right? So I see that A is green and it's above math. So I'm going to hit alpha in math and that gives me A, and I'm going to hit enter, right? So whenever I recall A, right, it's going to give me that full value. Okay, now I'm going to use that in the calculation. So we just write this out. So C, that's equal to the square root of A squared. So for A, I'm going to use 4.04, right? So I'm not using rounded value. I'm putting the dot, dot, dot to kind of let you know I'm using the full value, plus B squared. Okay, this is what I'm going to put into the calculator. All right. So I have the square root of A squared plus B squared. And now I'm going to round this final answer, and we have 8.08. All right, so C is 8.08. So now if we check our facts for the right triangle, notice that the hypotenuse must be the longest side in any right triangle. So notice that 8.8 is the longest side. Here's another fact about triangles in general. The biggest angle is opposite the largest side, and the smallest angle is opposite the smallest side. All right, so they don't actually give us the measure of angle A, but we can actually find it, right? If this is 90, B is 60, right? A would have to be 30 degrees, right? Because that would give us 90 degrees, that would give us 180 degree total. But just notice that the smallest angle is A, the smallest side length is A, the largest angle is C, and the largest side length is side C. So just those are facts that follow any triangle, not necessarily a right triangle. All right. Okay, none of these are asking to find an angle measure. All right, so at this time, okay, I would like for you to answer this question. Okay, notice we're not given a triangle. Okay, we're given dimensions. You have to sketch a triangle, and then you're asked to find side A and side B. Okay, I'll give you about 3 minutes or so, okay, because our time is running out. I'll give you about 3 minutes or so to attempt to work the problem, and then we will return with the solution. All right, now we're going to return with the solution. So we have C is equal to 60 and angle B is equal to 20 degrees. All right, so when you're using this standard labeling, okay, C is always going to be your hypotenuse. All right, so A and B are just arbitrary. So I'm going to call this A, and I'm going to call this B. All right, so we have side length A here, and we have side length B here. All right, we're given that side length C is 60, and we're given that angle B is 20. Right, so here again, we're going to use angle B as our reference angle, right? Simply because it's the only acute angle measure we're given, right? And we're going to find side length A, right? So that's going to require us to set up a trig function. So before we set up a trig function, we need to label our sides. So first, I want to start with the hypotenuse. So side C is our hypotenuse. Next, I'm going to label my opposite. So the opposite of angle B is side length B. And then lastly, our adjacent is side length A. Now, in order to find A, remember Chief Sakatoa, we're trying to find the adjacent. So let me just write that out again, right? We have to find the adjacent. So there's two formulas that use the adjacent, right? We're given the hypotenuse and we're given the angle measure. So here I'm going to use a cosine function, all right? Because I know my angle measure. We can find the cosine of our angle measure. We don't know the adjacent, but we know the hypotenuse. So we're going to set up a cosine function. So I want to write this out as the cosine of 20 degrees, right? So Chief Sakatoa, that's equal to the adjacent, which is the unknown side, A, divided by the hypotenuse, which is 60. We're going to solve for A, right? So in this instance, we're going to divide both sides by 60. Right? We've solved for A, so now we're going to use the calculator. Right? So I'm in degree mode. So this is 60 times the cosine of 20 degrees. And we have 56.4 degrees. Oh, excuse me, that's not degrees. We have 56.4 in length. Right? So 56.4 is equal to A. Now we're also asked to find B. Right? So in order to find B, we can use the Pythagorean Theorem. So remember that formula was B is equal to the square root of C squared minus A squared. Right? So again, I'm going to take that previous value, that 56.3 3815. I'm going to store that for A. Right, I'm going to store that for A. And then I'm just going to write this out. So B is equal to C squared. So C is 60. All right, so that's 60 squared minus A squared, which is 56.381. That keeps on going. So I'm going to put this in the calculator as the square root of 60 squared minus A squared, and we have 20.5 for B. So B is 20.5, A is 56.4. All right, and we just kind of align that to the facts. Notice that my longest side is C, which is my hypotenuse. My smallest angle is 20 degrees, right? And the side length opposite is the smallest. All right, so if we actually had to find angle A, right, keep in mind that B and A are complementary. They must total to 90 degrees. So angle A must equal to 70 degrees. All right, so at this time, I'm going to stop the recording.